this particle will be after some time here, after some time this will be here, and after some time this will be here. I have chosen only 4 points. There can be infinite number of points. So at this point P, at this point P, suppose I want to find the direction of the velocity. So I have told you that direction of the velocity will be at point P will be tangent to that point. So this will be the direction of the velocity at this point. Now at this point the direction of the velocity will be like this, and at this point the direction of the velocity will be like this, and at this point the direction of the velocity will be like this. So here at each and every point you can see here, you can take any point on the circle, any 2 points on the circle. The direction of the velocity will always be different. No matter the particle is moving with a constant speed or with a variable speed, no matter, there will be always change in the direction of the velocity when the particle is moving in a circular path. So keep in mind first this point. And if I am talking about acceleration, so what do you know acceleration? Acceleration is basically change in velocity. What is the cause of the acceleration? Change in velocity divided by change in time. Basically you can say if the velocity will change, time is changing continuously. If there is a change in velocity, then there will be the acceleration. So now here, this is the velocity at point P. Suppose this is point A. This is point A. This is point B. This is point C, and this is point D. So what is happening? The direction of the velocity is changing at each and every point. Direction is changing. Direction. Okay. Here direction is changing, and I have supposed that the magnitude is constant. This can the magnitude of the velocity means speed can be constant and it cannot be constant. We will discuss later. So here I have supposed that speed is constant and direction is changing. So now what is velocity? Velocity is the magnitude of velocity, that is speed, and there is one more thing, direction. If you want to change the velocity, for the change of velocity, either the speed should change or the direction should change or both should change. But here what is changing? Direction is changing. So direction of the velocity is changing means you can say that indirectly the velocity is changing, and change in velocity will produce the acceleration, and that acceleration is known as the centripetal acceleration. And remember, this centripetal acceleration always act towards the center. Suppose at this point I want to find the direction of the centripetal. I am not talking about the magnitude now. I am just saying the direction of the centripetal acceleration. So the centripetal acceleration at this point will be in this direction, and at this point the centripetal acceleration will be towards the center. At all points the direction of the centripetal acceleration will be toward the center. So remember this point. And why? What is the reason of the centripetal acceleration? Change in the direction of the velocity. Change in the direction of the velocity. So in circular motion, at every point the direction of the velocity changes, and due to this there is an acceleration towards the center at every point, known as the centripetal acceleration. Finished. Okay, here already I have written here, so there is no need to write down this. Acceleration is basically change in velocity divided by change in time or time. So okay, now this centripetal acceleration is given by this particle P is moving with a constant speed of v. With a constant speed of v. Okay. Here I have supposed that this particle P is moving with a constant speed v. Okay. And r is the radius of the circle. And remember that in a circular motion, this expression is always valid. V is equal to r omega. Speed of the particle is equal to radius times of the angular velocity. This is always valid in circular motion. In circular motion, I told you this is valid. So now, centripetal acceleration is given by the formula v square divided by the r. Okay, and this is the first formula, and this centripetal acceleration can be written as, we know that v is equal to r omega. So you can write this as r omega into r. It will become r square into omega square divided by r, and r will be cancelled out. So it will become r omega square. So centripetal acceleration can also be given by r omega square. So both these formulas will be used according to the need. Both these formulas will be used according to the need. First formula, r is the radius of the circle, v is the speed of the particle, omega is the angular velocity of the particle. So this is the centripetal acceleration, and at each and every point you can say, you can see here, at each and every point the direction of the velocity is changing, and also the direction of the acceleration will also be changing at each and every point. It is towards the center, but see, at point B, centripetal acceleration is towards this direction. Here the centripetal acceleration is towards this direction. So basically centripetal acceleration is always changing with time. Always changing with time and direction. Okay. So here you can write one additional point. The direction of the centripetal acceleration, the direction of centripetal acceleration is changing continuously. And what about the magnitude of the centripetal acceleration? This will depend upon the speed of the particle with which the particle is moving. If the speed is changing, then the magnitude of the centripetal acceleration will change, or omega will change, then the magnitude. But direction of centripetal acceleration will always change. Okay, this is all about the centripetal acceleration. After that, another type of acceleration is tangential acceleration. Okay, tangential acceleration. So 4 point I have chosen, and particle P is there. P is the particle, and this particle this time is moving with a variable speed. Okay, particle moving with a variable speed. So at this point, the direction of the speed, direction of the velocity is this, and at this point the direction of the velocity is this, and at this point the direction of the velocity is this, and at this point the direction of the velocity is this. This time I have made this arrow is shorter, this arrow is somewhat larger than the previous, larger than the previous, and larger than the previous. So basically here the velocity is v1, magnitude of the velocity is v1, and magnitude of the velocity is v2, and magnitude of the velocity is v3, and magnitude of the velocity is v4. Means this time the particle is moving with a speed which is changing continuously, Suppose this is point A, B, C, and D. You can choose any number of points on the circle, and here I am saying the speed is increasing. Speed on a circle can decrease also. Speed on a circle can decrease also. And here now, due to the change in the magnitude of the velocity in a circular motion, due to now what is happening in this circular motion? Here direction always change. Direction is always changing, and due to the direction there is acceleration, centripetal acceleration, finish. Now talking about the speed or the magnitude of the velocity, here at each and every point the magnitude of the velocity is changing. So what I have told you, if you want to change the velocity, either the direction or the magnitude should be changed. Velocity, magnitude plus direction. So direction is changing. Due to the change in the direction, there is a centripetal acceleration, and due to the change in the magnitude, there is a tangential acceleration. Because if the magnitude will change, then also the velocity will change. So don't confuse here. So this is due to the change in the magnitude of the velocity, that is known as the speed, and magnitude of the velocity I will represent mod of v. Mod of v is the magnitude of the velocity, because magnitude can never be negative. So that is why here we have put mod here. So now how we will define the what is the formula to calculate the tangential acceleration? As the speed is changing at different points, so this is the formula to calculate the tangential acceleration. dv by dt will be the tangential acceleration. What is v? V is the magnitude of the velocity. And what is the cause of the tangential acceleration? Change in the magnitude of the velocity. Okay, so now talking about the direction, always remember that the direction of the tangential acceleration is parallel to the direction of the velocity. Parallel to the direction of the velocity. I am not saying always in the direction of the velocity. Parallel to the direction of the velocity. Here the velocity is increasing. So you can say this will be the direction of the tangential acceleration. Okay, this will be the direction of the tangential acceleration. In this case, as the velocity is increasing, you can write here v1 is greater than v2 is greater than v3 is greater than v4. So direction is tangential. Basically, direction of the tangential acceleration is tangential. Tangential means suppose a circle is there. For example, a circle is there. This is a circle now. So at this point, this is a point, and at this point, what can be the direction of the tangent there? There can be two direction of the tangent like this. There can be the two direction of the tangent. One direction is in this direction and another direction is in this direction. So tangential acceleration can either be in this direction, tangential acceleration can either be in this direction. Okay. So basically the direction of the tangential acceleration will be tangential, or the direction of the acceleration sometimes toward the direction of the velocity, sometimes opposite to the direction of the velocity. Okay. So this is the tangential acceleration in a circular motion. And why there is a tangential acceleration? Due to the change in the speed, dv by dt, rate of change of speed, due to rate of change of speed. Okay, so now After this, on a circular path, if the velocity is decreasing, if the velocity is decreasing, or the magnitude of the velocity is decreasing, suppose this is v1, this is v2, this is v3, okay, and your v1 is greater than v2 is greater than v3. So what is the meaning here? uh, the magnitude of the velocity is decreasing. In that case, the direction of the tangential acceleration will be opposite to the direction of the velocity, like this. This will be the direction of the tangential acceleration. Okay, because this time will be the retardation. Okay, retardation is the negative acceleration. Okay, if the velocity is decreasing, then the direction of the acceleration will be like this. Okay, so no need to write. So at different points, if the velocity is decreasing, then the direction of the tangential acceleration will be opposite to the direction of the velocity. Tangentially opposite you can say. After that, there is a net acceleration. What is the meaning of the net acceleration? The vector summation of tangential acceleration and the centripetal acceleration is the net acceleration. So net acceleration, okay, now if a particle, suppose this is a particle P, and this particle is moving in a circular path with changing speed, means the speed is also changing, means the magnitude of the velocity is also changing and direction is also changing. So due to the change in the magnitude, what type of acceleration will be there? Tangential acceleration. And due to the change in the direction, there will be the centripetal acceleration. Okay, so suppose at point P, I want to calculate the centripetal and the tangential acceleration. Centripetal and the tangential acceleration. So at point P, what is the direction of the centripetal acceleration? Towards the center. This will be the direction of the centripetal acceleration. And at point P, what is the direction of the tangential acceleration? If the speed is increasing in this direction, so you can say tangent to the. So this is the tangential acceleration. Now, vector summation means these are two vectors. This is one vector. This is another vector are acting at 90 degree, because this is the radius, na? This is the radial direction, and this is the tangential direction. Radial direction and tangential direction are perpendicular. So how can we find the magnitude of the resultant or net acceleration? That is equal to under root of centripetal acceleration square plus tangential acceleration square. And what is centripetal acceleration? V square by R or R omega square. What is tangential acceleration? dV by dt. Okay. Vectorically, if you want to see net acceleration, okay, so how you will find the vector sum? Two vector acting at 90 degree, like this you will find. You will draw a parallelogram, and suppose this is the direction of the net acceleration, and this net acceleration is suppose making an angle of alpha with the tangential acceleration. For example, for the direction I am writing, this angle is alpha. Okay, this angle is alpha, and this is the angle made by the net acceleration with the tangential acceleration. So with the help of the, you can say, geometry, you can just find this tan alpha, na? How can you find this? So basically just I am completing the diagram. So basically you have centripetal acceleration like this, and you have tangential acceleration like this. Tangential acceleration. So what you will do, you will just draw a line perpendicular to this and draw a line perpendicular to this, and what you will get the resultant acceleration. You will get the resultant acceleration. So basically this will be the resultant acceleration. Okay, this will be the resultant acceleration, an. Length of the arrow is equal to this, and length of this arrow is equal to this. Okay, so basically this angle alpha you want to find, this angle. So now see this triangle, triangle OAB. Suppose this is A and this is B. So in triangle OAB, can we find tan alpha? Tan alpha is this is a right angle triangle, na? Because this angle is 90 degree. This angle will be 90 degree, na? So in this right angle triangle, this AB will be perpendicular. And what is hypotenuse? Hypotenuse this OA. Oh, sorry. Tan alpha is perpendicular divided by base. So this is opposite to the angle is perpendicular, and opposite to 90 degree angle there is hypotenuse, and this is the base. So OB is the base. OB. So tan alpha, you can find AB. What is AB? Who will tell? Divyangi, what will be the value of AB? As this is a parallelogram. In parallelogram, opposite sides are equal.
Centripetal acceleration.
Yeah, AC. It will be AC. And what is OB, Hiba? OB?
Tangential acceleration.
Yeah, tangential acceleration. So now tan alpha, or if you want to find the alpha, then you can write it as tan inverse A by C, or it is better to learn this AC by ET. And they can ask you like this also. They can ask you like this also. If alpha is not given like this, if the alpha is given, suppose they are asking find the angle of the resultant acceleration with the centripetal acceleration. If suppose this angle is you have to find, then in that case this will be changed. Tan theta, when you will apply the triangle, when you will do the trigonometry, you will get 80 by AC. Okay, so accordingly you have to change. So this is not mandatory. Always they will ask you the alpha means angle with the tangential acceleration. Okay, generally they ask. That is why I have written. So this is tan alpha. Basically, in this case, net acceleration. What you will say about the net acceleration? Net acceleration is due to the change in the direction of the velocity as well as change in the direction of the magnitude. So I am not going in the definition and all that. Okay. So basically we have to focus what is the cause, and here why this is the net acceleration. Net acceleration is basically the vector summation of the tangential acceleration or the centripetal acceleration. Sometimes this tangential acceleration is known as the parallel acceleration. Okay. Why parallel? Because direction of the velocity is in this direction, and this centripetal acceleration is known as the perpendicular acceleration. Okay, so here in this case, mainly you have to know what is the net acceleration in circular motion and what is tan alpha. Okay, so note down. Then we will solve the questions on it. So if you will follow this way to analyze the acceleration, I think it will be better to understand. Otherwise, the things will be messed up. And last acceleration, angular acceleration is, we will discuss later. Centripetal acceleration will always be there. Okay, if the body is moving on a circular path, because on a circular path there will always be change in the direction of the velocity, always. When completed, ask me to scroll down, or just you can write the in the chat box. So here I have assumed that the particle is moving with the constant speed. So particle, okay, no problem, it's okay. You can understand. From where you are observing the motion, from the center. Completed? Okay. So cause of acceleration is basically change in velocity. And velocity can be changed by either changing magnitude or either changing the direction. So centripetal acceleration is speed squared divided by the radius of circle is equal to r into omega square. Okay. Completed, Hiba?
Yes, sir.
Okay. Write down. So for analyzing any vector quantity, now first analyze the what is magnitude, then analyze the direction. In this case, direction we already know. We have to work on the magnitude. Direction will be either tangential direction, either the perpendicular or toward the center. Complete scroll down.
Yes, sir.
Yes, sir.
So this can also be the case. The direction of the tangential acceleration can be opposite of direction of the velocity also. If the velocity is decreasing, like in case of the, there are two types of acceleration. One is acceleration, another is acceleration that is known as the retardation or deceleration. So what happens in case of the retardation? Suppose you are on a bike and you are on a car and applied the brake. The direction of speed, you are going in forward direction, but in that case there will be the retardation. Retardation means the direction of the acceleration will be negative to the opposite to the direction of the velocity in that case. So that is the case here also. Here the velocity is decreasing, so that is why the direction of acceleration will be opposite to the direction of the velocity. So we cannot say that always the direction of the tangential acceleration will be in the direction of the velocity. Generally in 90% cases it happens. So not only on this point, you can find the direction of the net acceleration at any point. At this point also, the direction will be decided. At different point, the direction of the net acceleration will be different. What you have to do, you have to draw a tangent and you have to draw a perpendicular. And accordingly, vectorically, you have to add the both the acceleration. Okay, write down fast. Okay. Completed. Okay, so now we will solve the question after this. Separately solve the centripetal acceleration, separately solve the tangential acceleration, and you already know both are at 90-degree angle, and add them vectorically like this. And if you want to find the angle, then use this formula. Okay, so now see here what we have done. Centripetal acceleration first. It is due to the change in the direction of the velocity given by v square by r omega square. Another is tangential acceleration. This is due to the change in the magnitude of the velocity. At is given by rate of change of speed dv by dt. Net acceleration due to change in the magnitude as well as direction. It is given by dv by dt. Or you can write it as under root of centripetal acceleration square plus tangential acceleration square. So basically dv by dt total change in the velocity. So first question. First question is this. If v is equal to 2t is given and r radius of the circle is 9 meter. Find centripetal acceleration. Basically a particle is moving in a circular path and this is the given information. See, speed of the particle is changing with time like this. We have, and radius of the circle is this. We have to find centripetal acceleration, tangential acceleration and net acceleration at t is equal to 3 seconds. So basically we have to find the centripetal, tangential and net acceleration. Okay, so I am just supposing at time t the particle is here. Okay, at time t the particle is here. I don't know where it will be, but at time t the particle is here. So first thing, centripetal acceleration. Centripetal acceleration is basically v square by r. V square by r. So what is v? V is 2t. Without the diagram also you can solve this. 2 square by r. So it will become 4t square divided by r. It will be 4. T square means 3 square. What is the radius? 9 meter. So it will become 3 3s are 9. So it will become 4 meter per second square. Now this is the speed, no? Speed. So tangential acceleration will be dv by dt, d mod v by dt, because mod v is here v. So I am writing dv by dt simply. So what will be dv by dt? D of dt of 2t. So it is equal to 2 meter per second square. Now net acceleration is under root of tangential acceleration plus centripetal acceleration, that is equal to 4 square plus 2 square. This will become, I think, root 20 meter per second square. Now if without the diagram, if you want to just solve this question, you can just simply find the tan alpha. What will be the alpha? Alpha is the angle of the resultant, that is an, with the tangential acceleration, that is given by ac by at. So what is ac? AC is 4, AT is root 20. Hmm. Oh, sorry. AC is 4, AT is 2. So it will be 2. So it will become 2. So 10 alpha is equal to 2. So alpha will be 10 inverse of 2. From the diagram, if you want to see, then from the diagram you can see, suppose at time t the particle is here, so this moving in this direction. So suppose there will be the two types of acceleration. First is centripetal acceleration, like this, in this direction, that is AC, and here will be one another acceleration, tangential acceleration. So what is the value of the tangential acceleration? 2 meter per second square. What is the value of centripetal? That is 4. And resultant, you will get something like that. And angle, you have just find it. This is alpha. This is basically the net acceleration. Okay, this is the net acceleration. First question, and there is another question. Okay, so first write down this because we have a limited time. Okay, write down fast. So after a time t, I have supposed the particle is here. So without the diagram also you can just solve the question easily. This alpha is the angle of the resultant acceleration with the tangential acceleration. If suppose they are asking angle with the centripetal acceleration, simply what you have to do, you have to do 90 minus alpha. It will be better, 90 minus alpha, because the angle is 90. Okay. Hiva, completed?
Yes, sir.
Okay, so 10 alpha is AC by 80, 4 by 2, 2, and alpha is 10 inverse 2. And remember, this alpha is with the tangential acceleration of resultant acceleration. So now we will solve this question. and comparatively harder. A particle P is moving in a circular path and omega is given. Angular velocity of the particle is changing with time. Radius of the circle is given 2 meter, and find the time after which the AT makes an angle of 37 degree with AN. Very simple question. So we do not know what after what time the angle will be this 37 degree. Okay, so basically 10 alpha you want. Okay, 10 alpha you want, and 10 alpha is given as 37 degree, and that is AC by 80. Okay, this is AC by 80 and 37 degree. This is given, and this is equal to AC by 80. We do not know what is AC, what is 80. So first calculate AC. AC is given by V square by R or omega square R. So omega is given, so we can write omega square into, and R is 2. So it will become 8t square, I think. 8t square. So with the help of omega square R, not for the tangential acceleration, there is a requirement of dv by dt. And we know that v can be written as R into omega. So dv by dt of R into omega, R is 2, omega is 2t. So it will be 2 to the 4 is out of the integration. So it will become 4 of dt by dt. So basically you will get 4 meter per second square. Okay, meter per second square you will get. Now simply put the value and get the answer. This is 1037. There is a special type of triangle, 37 degree, 3, 4, 5, and 1037 will be 3 by 4. So put here 3 by 4. What is AC? AC is 80 square, and 80 is 4. So what will be the answer? Root 3 by 4. 4 and 4 will be cancelled out. From here you will get root 3 by 4, 3 by 8 meter per, not meter, second. So with the help of the diagram, if you want, suppose after a time t, the particle is here, and this is the direction of the tangential acceleration. This is the direction of the centripetal acceleration, and this is the net acceleration. And this is making an angle of 37 degree. Okay, so this time we want to find. Okay, write down fast. So do you want to ask any doubt, Dibyangi and Hiba?
No, sir. Dibyangi, do you have any doubt? No, sir.